So in section 3.3, we're going to be looking at some other formulas, and these are called our sum and difference identities or sum and difference formulas. We've spent a lot of time talking about those special angles for the unit circle. What these formulas are going to allow us to do is open up that window and be able to find the exact value for other angles that are not specifically on the unit circle. So by using these sum or difference identities, what we're going to be able to do is we're going to find the exact answers of trig values that are not common on the unit circle. But these values are going to be based on the angles that we've studied from the unit circle. So the idea is what we want to do is when we look at an angle, we want to add or subtract two angles from the unit circle to produce that particular angle that we're asked to find the exact value for. So for example, the first formula is our sine sum formula. Again, we have our sum formulas because we're going to add two angles together. So alpha and beta are other Greek variables that are used to represent an angle measurement. We've been looking at theta, but this is alpha, this is beta. Again, these variables are used to represent an unknown angle. So sine of alpha plus beta is the formula sine alpha cosine beta plus cosine alpha sine beta. So for example, the idea is if I want to find the exact value, let's say of sine of 40 degrees, the idea is I want to pick two angles that are added together to give me 40 degrees. For example, I could use 15 degrees and 25 degrees. And again, this would be considered my alpha, this would be considered my beta. And I would just simply substitute 15 degrees into this formula for alpha. I would plug 25 in for beta. So sine of 15 degrees cosine of 25 degrees plus cosine of 15 degrees sine of 25 degrees. And again, the idea is these would be angles from the unit circle, and then I would, for example, look on my unit circle, find what that exact value would be from the unit circle. So the idea is the two angles that I'm going to add or subtract together need to be angles from the unit circle. For example, a 30, a 45. We could even go out of quadrant 1 into quadrant 2. We could use 90 degrees. We could do 180. The object is picking the two angles that add or subtract together to give us. Some of the problems, there's more than one correct pair you could be picking. The next one is your cosine alpha plus beta formula. So again, this formula is going to be your cosine alpha, cosine beta, minus, now notice, be careful, even though it's our sum formula, in the formula, it's a minus sign. Sine alpha, sine beta. So just be careful, this one has the minus sign in it. So even though we're adding two angles together in your actual formula, it's a minus. Then you have your tangent of alpha plus theta. So tangent alpha plus tangent beta all over 1 minus your tangent of alpha, tangent of beta. So those are your sine, cosine, and tangent sum formulas. So now let's take a look at the difference. You may find two angles that you need to subtract together. So again, my difference formula for sine is going to be your sine alpha, cosine beta, minus cosine alpha, sine beta. So if you need to subtract two angles together, then you would have to, and you wanted to find the sine of an angle, you would pick the sine difference formula. Next is your cosine difference. So this is going to be your cosine alpha, cosine beta, plus, now notice it's the opposite, just like that cosine sum was, plus it's going to be your sine alpha, sine beta. So there is your cosine difference formula. And then finally your tangent difference. Tangent alpha minus tangent beta all over 1 plus tangent of alpha, tangent of beta. So that is these are the 6 formulas we're going to be using actually in the next 2 sections. Now recalling from the unit circle, remember in radian, 0 degrees is 0, 30 degrees is pi over 6, 45 degrees is pi over 4, 60 degrees is pi over 3, 90 degrees is pi over 2. Remember the ordered pair at 0 degrees is 1, 0. Remember the ordered pair at 30 degrees is square root 3 over 2. 1/2. At pi over 4, it's square root 2 over 2, square root 2 over 2. At 60 degrees, it's 1/2, square root 3 over 2. And remember, at 90 degrees, or pi over 2, it's 0, 1. Remember, the coordinate is the x and the y value. Remember, from the coordinate, the sign is your y coordinate. So remember, the sign of 0 is 0. The sign of pi over 6 is 1/2. The sign of pi over 4, square root 2 over 2. The sign of pi over 3, square root 3 over 2, and then the sign of pi over 2 is 1. Remember, cosine is your x coordinate. So then the cosine of 0 is 1. The cosine of pi over 6 is square root 3 over 2. The cosine of pi over 4 is square root 2 over 2. The cosine of 60 degrees, or cosine of pi over 3, is 1/2. And the cosine of pi over 2, or 90 degrees, is 0. Remember, tangent is our y over x values. So the tangent of 0 degrees is 0. The tangent of pi over 6 is square root 3 over 3. Tangent of 45 is 1. The tangent of pi over 3 is square root 3. And then the tangent of pi over 2, don't forget, is undefined. All right? So again, it's all based upon these special angles from the unit circle. So the strategies we want to use to find the exact value by using our sum and difference identities. The first thing we want to do is we want to determine two angles, or two common angles, or two common values, whose sum or difference is the given angles. So in other words, we want to pick two angles from the unit circle, add them together, or subtract them together to come up with the same value as that given angle. For a problem, like I said, there may be multiple combinations. There may be more than one correct combination, and you'd still get the same answer regardless of the combination as long as you applied the correct formula. And then you're going to use the appropriate sum or difference identity or formula. Evaluate those common trig values, so you should be able to pull those values that you've substituted into the identity off the unit circle. And you want to simplify your answer with no radicals in the denominator. When possible, when you're trying to pick your angles, try and pick the angles in quadrant 1 as much as you can. You may not always be able to, and the reason why is that way you don't have to worry about dealing with negatives. But you may have to pick angles out of quadrant 1. But the goal is pick angles from quadrant 1 if you can.